Good morning, everyone. Welcome to Tuesday. I'm Jeremy Meal with Gensco Tech Team. Today we're going to go over furnace troubleshooting. We're going to talk about codes. We're not going to go super deep into them. We're going to go talk about all the codes and basically how to break them down. We're going to talk about 40-inch furnaces, some of the legacy 40-inch furnaces. We're going to talk about some of the new shorter cabinets as well. So we're going to kind of look at both halves of gas furnace troubleshooting as far as 40-inch and the new shorter cabinets, so the S-series style furnaces. So if you don't know, the 253-620-8282 number is a call or text number. That is our main tech line. So if you need help out in the field, whether it be Mitsubishi or Trane American Standard, that is your number to call or text, and we'll make a ticket for you and get you a call from that respective team. Okay. So 253-620-8282 is that number. So let's dig into it. Okay, so really, troubleshooting really starts at knowing the sequence of operation, what the expectation of that equipment is, right? All manufacturers kind of play by the same rules. We have the same settings because there's some ANSI standards and stuff like that for how gas furnace operations work, safeties, and so on. So knowing the sequence of operation for equipment is really going to be where you're going to start troubleshooting. What's the expectation? So in our install guide and service facts, we're obviously giving you the sequence of operations. So like this is out of a S-series furnace. So it's telling you for first stage gas heating, what it's actually going to do step by step. So this is very good on giving information to you guys of okay, well, we missed this step. Why? Is there do we have a switch out, or simply is the board making a bad decision, right? So we need to look at all these steps and see if it's actually working like it should. I would say on the S9V furnaces, it can be a little confusing because we get the call into tech all the time about it's showing HT2 when it's only in low fire. The S9 furnace actually shows what stage of operation is being requested, but not what actual stage of operation it might be in. So if that S9V2 furnace gets a simultaneous W1, W2 call because there's a jumper there, it's going to show heat 2, but it's going to be in low fire, right? So you're going to hook up to the gas valve and what have you, and you're going to see low pressure or first stage gas pressure. So knowing that sequence of operation, kind of what it's telling you, and then of course the little things like that, I guess the nuanced things like that, that system will do, is really going to be where troubleshooting starts. Okay, so I kind of put this in there because we get this call quite a bit on this IDL, which is idle, right? So it means the system's just sitting there waiting for a call. We get the call all the time. What's the 7P1 error code? It's not listed. It's not a code. It's just that idle upside down. So keep that in mind. You and your technicians are looking at a job, or a homeowner maybe snaps a picture and texts it into you and says there's some kind of code on the furnace. You can recommend that. That's just a standard waiting call. It's just idle. Okay. It's a call we get regularly enough. I figured I'd throw that in there. Okay. So flash and fault codes on 40-inch furnaces. So obviously we've got some green LEDs, we've got some red LEDs. Depending on the model of the 40-inch furnaces, we'd have a green CFM light as well. I didn't throw that in there, but let's talk about that real quick. That green CFM light, if you didn't know, is a light that is communicated from the motor module, so from the motor itself to the control board. And it is one flash per 100 CFM generated from the motor. So it's not board to motor telling you 6 flash, 600 CFM. It's actually the motor saying, I'm making 600 CFM, put 6 green flashes on that light. Okay. So CFM light aside now at this point, we have green LEDs flashing slow, normal, no call for heat, flashing fast. There's a call for heat there. It's totally normal. Fault codes are going to be red. So we have a continuous off. We obviously lost 24-volt power, right? Or main power is off to the system. Continuous on is going to be replace the main control board in that unit. Okay, so some direct call out codes there. You get into the S series furnaces. This was just stolen out of an S9V2 service fax. So we actually have called out codes, right? So on the 40-inch or legacy furnaces that we've produced in the past, we have very simple codes, right? 2 flash, 3 flash, 4 flash, 5 flash, and so on. Obviously, with S-series furnaces and having a segmented LED system, we have a lot of codes that we can echo out. So we can actually break out the switches much better than we could on the old 40-inch legacy product. So an example in that would be like a pressure switch issue, right? So now instead of just giving you a 3 flash and saying you have a pressure switch issue, troubleshoot 1 or 3 of the pressure switches involved, we can actually say E3.2 for open pressure switch first stage, right? Or 3.3 for shorted pressure switch second stage. So we're actually giving you a direct call out of which pressure switch we're seeing an issue with. So much more informative. Not that the old system was bad, but this one's much more informative. Of course, with E6.3, stuff like that, you're going to have igniter relay fails or igniter opens. So we get a lot of troubleshooting out of these newer furnaces than we did the older ones. Okay, so we're going to look at a system lockout at 2 flash. So it's going to be an automatic reset in 1 hour. So basically, gas is not being sensed on the call for heat. So it's a 2.1 error on the short furnace. Flame is lost 10 times during call for heat. That would be a 3.2 or a 2.2, excuse me, on the shorter furnace. First stage gas valve is not being energized, 2.3 on a S series furnace. So obviously, when we have a first stage error not being energized, we're going to look, right? Why isn't the gas igniting? Do we have the right pressure in and out? The maximum pressure inlet you can have on any of our gas valves is no more than 14. So in an LP situation, we can see where we can have pretty high inlet pressure, which could hold off our gas valve from doing what it needs to do. So we're going to look at gas pressure, what's coming in, what's going out. We're going to check the igniter, make sure it glows. What's the ohms? What's the position of it? Is it in the hot spot on the burner? And what kind of igniter is it? Is it 80, 120 volts, so on? So obviously flame's not being sensed. So are we carrying it across all the burners? Are we getting a full light of that burner face? So we can obviously check that with flame current checks. So 2 to 4 is normal. On the S series furnace, we make it pretty easy. We have pots there that you can put your meter on and actually check directly. On the older 40-inch furnaces, it was a little different. You'd have to span a meter in there, and we'll show some pictures of it there, how to do that. But so we're looking to see what the gas pressure is really. We're going to check the igniter. Does it glow? Does it have ohms? Is the positioning good? Is the flame not being sensed? If it is lighting, why isn't the flame being sensed, right? Do we have a dirty burner issue? It's not coming all the way across. It's not hitting a flame sensor. Those kinds of issues we're going to look at. Okay, let's go into checking gas pressure. This would be on a standard 40-inch furnace. Obviously, this is an older style valve. All these manufacturers, us included, use this style of valve. So incoming gas pressure must be more than 4.5. So half pound on a residential system, natural gas, and then less than 14. So remember, that's the maximum that valve can open up against. Okay, verify the required manifold pressure. So not less than 1.4 for the first stage and not more than 3.5. Obviously, with mod furnaces, this can change a little bit. First stage on mod furnaces, I believe, is 0.7. So for most models of that mod furnace. So it may change a little bit, but on a standard 2-stage gas valve, no less than 1.4, we got to keep that burner face lit. And not more than 3.5 or 3.2, depending on the models. Okay. So you're going to remove a port plug and install that barb fitting to be able to access that. This is an open burner style, so you do not have to reference the burner. If it was a sealed combustion unit, like a 90%er would be, then we're going to have to reference the burner port to actually get true values there. So we'll show some pictures of that as well. Okay, on the S series furnaces, we're using a J valve, White Rogers standard valve. So we have, this is obviously a two-stager. A single stage would have just one adjustable connector here. So this is showing you high and a low. So this would be a two-stage valve. Single stage would just have one. We have these inlet pressure bosses, and there's a little Allen screw that goes in here that is secured down. So what you want to do is you want to get your Allen wrench and just loosen it up. You don't have to take it out, just loosen it up. And then you're going to slip your tubing right over the top of that boss. It's like a castle wall, if you will. And that little Allen wrench is down there in that boss a little bit. So we have the inlet pressure boss. Then when you obviously take your tubing off, you want to tighten that guy back down. So that's your inlet. So that's your incoming gas pressure. So that's where you're going to check for no more than 14, more than 4.5 coming in, right? And then of course LP is going to change that a little bit. And then you have your gas pressure to the burner in the furnace itself. So it's actually what that gas valve will be feeding that burner. Okay, so that's where you're going to make your adjustments out of that guy there. Install guide does say when you pull these, either they're black anodized or brass low or high caps, you want to put your thumb over them, make the adjustment, put your thumb over them to basically seal them back up, or put the cap back on it so it's actual. Okay, that is a recommendation from the manufacturer itself. So on the S series furnaces, we're going to go with either a single or two-stage J style valve. Okay, so we're going to check gas pressure on an 80% gas. We're just going to connect the manometer straight to the gas valve. We get into 90 or sealed combustion units. We are going to reference the burner box. We don't have these on the new style S because we do not have sealed combustion. So you're going to plug straight into the gas valve on those models. You get into the older legacy stuff, you're going to go into you're going to reference the burner port for sure. You have to have a dual pipe manometer to make this work and a T-fitting. So when you get into the mod furnaces and stuff like that, you have to do this correctly. Otherwise, you're never going to get your stuff set up correctly. And then you'll get PS1 issues all over and over again because that mod furnace doesn't understand because you didn't reference it properly. So when you did your gas valve minimum maximum setup and you didn't reference the burner, it's not going to be right. It'll never be right. So if you have a mod furnace out there with PS1 issues, I would highly recommend you connect to it properly and do that test, gas valve minimum, gas valve maximum setup, so it knows what distance to play into, what the low and the actual high is. So here's a good picture of the mod furnace right out of the install guide. It's showing you slope gauge, of course, standard manometer work just fine. But we need to hook into it and reference the burner box to actually set this up correctly. Otherwise, you're just asking for trouble. Okay, so silicone carbide, hot surface igniters we used on furnaces in '92. We still use them on the UC Builders models. Obviously, we're phasing out the 40-inch cabinets. It's carbide, so you never want to touch the carbide aspect of it. Isolator touch only. It's a 120 volt unit. It's 45 ohms at room temperature. 40 to 75 would be the working range at room temp. So pretty much every manufacturer has some rendition of this igniter, whether it's a wider base or has a different slit to actually lock up into. So, but this is one we've used for a very long time. It's definitely one you should have on your truck in the heat season, right? So we're going to talk about silicone nitride. This is an 80 volt. We've really kind of went away from 80 volts. Chip availability was a big problem for the 80 volts. So we've kind of stepped away from them. Easy way to identify them for the most part is the square ceramic body. Most 120 volts, I say most 120 volts, are round in the ceramic department and the 80s were typically square. That does not always, it's a good rule of thumb, but that does not always correlate. So this is an 80-volt igniter. It's 11 to 18 ohms. Some manufacturers let them go much higher than that, but we are going to stick with this one, 80-volt, 11 to 18 ohms at room temperature. Okay, so here's our hot surface igniter for 120 volt. So this is silicon nitride. It's built by Kyocera, 37 to 70 ohms. It's going to measure 50 ohms at room temperature abouts. It's going to be a 120 volt unit. So you can see in this picture that that ceramic is now round. So like I said, it doesn't always play across that way, but it is a decent rule of thumb. Okay. So when we look at them here, we have the nitride igniters that we use, one being 80 volt, which see how this one's round, so it can throw you off a little bit. It's not always true. 80 volt 145 is 80 volt here. It's a real long silicon nitride. Then we have the two shorter versions, 120 volt LP gas, and then we have the 120 volt 146, which is basically the same version of this with a longer isolator on it. Okay, so carbide. This is obviously another large brand Bryant carrier style igniter. So we're going to look at how igniters light, right? So it doesn't matter if it's 80 volt or 120. You're going to visually check it out, right? You always want to unplug an igniter when you're moving it, even if it's not calling, because there is some voltage there, okay? So especially in some manufacturers' product, Rheem comes to mind. If you take that igniter out while it's just sitting there idle and you do not unplug it, you can do some damage to the control board. Certain models, hopefully they've resolved that issue. So you always want to unplug igniters whenever you're moving them around, because if you tap them to sheet metal, there may be some voltage there. It may do some damage to the control board or the igniter itself. So we're going to visually inspect it. Is there hot spots? Is there cracks? Is there something wrong with it? We're going to look for voltage. If it's 120 volt during the trial, we're going to look for 120 volt. 80 volts really hard to do because that voltage peaks around, right? It jumps around all over the place because it has a learning routine. So really with the 80 volt igniters, we're just looking to see if they glow. And then of course, resistance at room temperature too, right? So I'll close this. So, so looking at it, visually inspecting it, attempting to fire with it, seeing what happens. Remember the sequence of operation at the very beginning, where you have to send in a call from the thermostat, right? And then obviously it does a self-check, make sure the pressure switches are in the specific position they should be in. So a pre-check, if you will. Then it turns on the igniter and does the inducer, excuse me, and then does a check after that inducer motor comes on, right? So then there's a check there to make sure that inducer motor did what it was supposed to do and close whatever respective switches it needed to. And then we'll go into preheat, right? So we'll preheat that igniter. And then after that timing is up, then we should get gas valve drop, right? So knowing that sequence of operation, you should be able to time that and go, okay, well, I dropped the gas valve and never saw the igniter. So visually, I think it's okay. It looks okay and all that. Now, is there voltage going to it if it's 120 volts? Yes, no. If it's 80 volt, you're just looking to see if there's voltage coming to it. It could be high, it could be low, as that learning routine happens. But definitely want to do that. So room temperature resistance, rule of thumb, 2 times the new resistance, 40 to 75 ohms is the window. I've had some dealerships say once they go over 100, we offer the homeowner a new one. That's up to the individual shops. But you can see in the slide deck, we have ohm values, very specific ohm values from the manufacturer that they consider good. So, all right, so silicon nitride. So we're going to check ohms resistance to room temperature at room temperature, right? So 11 to 17 ohms, 80 volts for our models. And then you have 37 to 70 on the 120. So You're also going to check positioning on the burner. So I know some guys were big on those Fireflies. They're great products. They're great universal to have on your truck, but you have to make sure you get that hot spot in the right spot. Otherwise, you're going to have heavy lighting or no lighting at all and eventual lockouts and homeowner discomfort. So we want to make sure that if we can, we provide the manufacturer specific igniter because it'll sit in the exact spot it's supposed to be and it'll light that furnace off. If we go into universals, we need to make sure that they are hitting where they need to hit. So there's two different positions for these igniters, and we'll show them. But we need to make sure we're hitting the hot spot. Like you can see in this picture, this is an 80 volt and it is not over the hot spot of the igniter. So it is essentially too tall, right? So this thing will light, but it'll probably light on the second attempt. Which could create a heavy lighting situation and of course a concerned homeowner if they can hear that. So let's look at burner faces with proper placements. So with proper placements in the hot spot, you're going to see the 80 volt igniter just at the edge of the venturi right there, right at the end of the diffuser. The 120 volt is coming over that cone just a little bit, just covering it. So, and that is right dead in its hot spot. So best reliability in the factory positions. Like I said, if you go with an aftermarket for convenience, or it's a Saturday call and you don't have that exact igniter, make sure it's lighting like it should. And you're actually get in there with a mirror and make sure that hot spot is where it needs to be to light properly. Okay, checking flame sensor. So obviously we got a flame proving rod. All the manufacturers use this. We're gonna, on the 40-inch furnaces, we're gonna remove the white wire. We're gonna have to put a jumper wire in there, right? So you're gonna connect your meter in series as a white wire with, and we're gonna look for DC microamps, right? So 1 is minimum to hold a valve open, 2 to 4 is typical. So obviously most technicians are just gonna pull this guy, hit it with a dollar bill or a sandcloth or something like that pretty quick just to clean it up, make sure there's no issues there, and then do this test. I'd say that's a safe way of doing it. So, and I always want to check this guy if you're having lighting problems. Okay, so if less than 2 microamps, then clean the flame sensor, check wiring and the ceramic. Maybe we have a cracked ceramic isolator. Maybe we've got a broken wire. There is always a little bit of voltage on that rod. A lot of people don't understand that, but that's actually a rectification circuit if you didn't know. So there is voltage on that rod coming down AC. Believe it's about 80 volts DC AC coming down there. And as soon as it hits and gets hot with that rod, then it comes back as DC voltage, and AC and DC can pass over itself on the same wire. So that furnace board is looking for that DC callback. So it's shoving down voltage being rectified, just kind of like a very crude laptop pack, right? When you get your laptop for the first time or a laptop and it comes with a little power pack in the cord, that's essentially what we're doing here. That's taking the AC wall power and turning it into DC voltage, right? This is a very crude mechanism of doing that, but it's basically the same thing. Okay, so we're sending voltage down to that flame rod, and then we're expecting DC voltage to come back up, and that board's watching that DC voltage. Okay, so flame rectification measurement. Obviously, we've made this a little easier as time has gone on. Instead of having to rig in a wire and all that and do a meter, you can simply now take your meter and get to the flame current on the control port. So you can see here, it's actually labeled 1 volts DC with 2 little pots here. So much easier on the S series furnaces to gather that information. Okay, so remember, one is minimum, 2 to 4 is typical. Okay, so draft pressure error. So obviously on a 40-inch furnace, we're just going to give a 3 flash. We can't really break those codes down as well as the S series furnaces. So S series furnace would be 3.1, 3.2, 3.3, or 3.4. So we're going to look in pressure switch errors, right? So pressure switches, guys, hardly ever fail. I think I've ever only really replaced 2 in my career. And I've had a pretty long career. So very, very rare. Usually the first thing that gets blamed when there's a pressure switch problem, but typically not the problem. Okay. So we're going to want to investigate why. Don't change the pressure switch right off the bat. We need to actually investigate why. So 3.1 is telling you pressure switch 1 is closed when it should be open. 3.2 should be open when it should be closed. If you guys are getting pressure switch errors on the S series furnaces, I would start to think you may have a tubing issue or something's not connected right. So I would direct my installers to start looking at the tubing. Make sure everything is where they should be. Maybe the tubing at the factory when the person was putting the tubing on, maybe hit the wrong spot, or even maybe even the wires for pressure switch 1 and 2 got swapped. So start looking at it holistically and then trying to figure out, okay, is pressure switch 1 actually pressure switch 2 wires? Did the wiring get switched? Maybe the tubing is not where it should be from either the manufacturer or from the installers. So just step back, get the install guide or service facts, and make sure everything where it should be. Grab your wiring diagram and go, yeah, okay, orange and purple go to pressure switch 1 and blue and yellow go here, and just look at it holistically, right? So hardly ever the pressure switch. All right, so draft pressure errors we're going to look at. Obviously, pressure switch error, is the inducer motor running? No. Okay, well, that's a problem, right? So we need to see if pressure switch 1 is closed. Is there voltage at the inducer, 120 volts, or even if it's a variable speed inducer? We're going to look if the board's sending any kind of voltage. Okay. So it could be a pre-check error, right? Knowing the sequence of operation, we're going to send voltage down those safety circuits, rollouts, limits, pressure switches, just make sure that they're all maybe closed if it's a safety set of series, right? And then we're going to make sure that the pressure switches are open because we can't see voltage coming back, right? So we're going to send voltage out. It doesn't come back. We know that switch is open. So if the switch is closed, then all of a sudden we see a callback and we'll never turn the inducer motor on, right? Because we know that that switch is in a position it shouldn't be in, right? So if no, we're going to see if the actual switch is closed. Maybe there's some water in the line somehow, some condensed water in that pressure switch line. Maybe it's a plugged port or something like that. So we need to figure out what's going on there with that pressure switch. If yes, we need to check the pressure switch to see if it's closed, right? So we're going to check pressure across the switch. We're going to check the vent system and even maybe the condensate drain. Okay, S9 with intermittent 3.1. It can happen. On windy days, typically, pressure switch is closed, but the inducer motor is not running. The wind is hitting the vent, causing a natural draft through the furnace. That PS1 is only a 0.2, so it can happen. Also, if you have to run the air inlet out, for most jurisdictions, you have to run it all the way out with the vent or in the vent's area. It has to be on the same side of the home. So in this situation with this air inlet in the garage or what have you, if we needed to run an intake, we'd have to run it on the same side of the building. We could not run the intake air over here because that can affect how the system or air moves through that furnace, right? So that's one thing to keep in mind with the S9 furnaces, has to vent or intake on the same side. Okay, but high wind can do it. So testing pressure switches, 80% are going to have a single port. They are open burner, so you do not have to reference the open burner. So we want to tee in, excuse me, and check the position. So before the unit turns on, we're going to see if we have a closed switch or an open switch. Then we're simply going to tee into it. We want to tee into it and see it actually live, okay? We don't want you to have one manometer tube and pull it off and push it on and then go to the switch and go back and forth. simply tee into it and see what the inducer motor is doing against the pressure switch live. Okay. We should easily be able to make more than the pressure switch rating, provided something isn't hung up. So 90% furnaces have dual ports. We got to reference the cold header or the intake air going into that burner. So we're going to tee in, we're going to get a manometer and reference the burner to be able to get true readings. So we're teeing into the pressure switch and into the reference the burner there. So you're going to have some tees with you. If not, Lowe's has got them for pretty cheap. Get you a couple. Okay. So variable speed, three-phase induced draft motors. This is the big confusion in the field with guys that haven't seen this legacy product or even never worked on this train unit, because usually the conversation I have on the person on the phone is, well, no, this is not a three-phase unit because it's a 120 volt residential unit. Well, that motor is three-phase. Okay. We did have a square body one. So this motor you see in this picture is a round body. We did have an older one that was square in variable speed. I'm going to tell you right now and save you a lot of time. If you have a square body inducer motor and you're having pressure switch errors, you think it's a control board or you think it's the inducer motor, I'm telling you, yard it out, because you're not going to be able to get that inducer motor and Wi-Fi it. You're going to get an inducer motor kit that's going to have this round inducer motor, a new control board, and some harness changes. So if you run into one of those old variable speeds, you're questioning the control board or the inducer motor for any kind of 3 error, you're pretty much done at that point. You either can move them onto a new furnace if they choose to go that route, or you can buy the kit and switch it over to this style inducer motor. Okay, so don't fight it. So all 8 model upflow jet and flows, 2, 3, and mods are going to have these variable speed 3-phase inducer motors. Okay. All right. So let's talk about these control voltages and frequencies, right? So we have the fan control, the IFC. So the main control board takes that single phase and converts it over to 3-phase. Train has never produced voltages for that inducer motor. So if you call up and say, what should it be putting out? We don't know. They've never told us accurately, low stage is this, medium is this, and high is that. Okay. I will tell you on the variable speed units, if you have a leak in the heat exchanger, that motor will do whatever it has to do to try to pull that switch in. So if you call and you say, I have this variable speed inducer motor and it is just going gonzo fast and it can't make that pressure switch, you got a leak somewhere. You got a leak in the heat exchanger somewhere. You got a leak in the RCT fitting behind the inducer, something, right? Because it is going to try to ramp up and make that switch versus a standard motor, which doesn't care, right? The speed it runs at, the speed you get. So there is a 4-pin connector on the board for this guy. So how you're going to troubleshoot it knowing we don't have voltages we can run on. So obviously we're going to shut the power off to the furnace. We're going to unplug the induced draft blower motor from the wiring harness. So we're going to unconnect it, make the motor stand alone completely. And then we're going to measure the resistance between like a 3-phase motor, right? So L1 to L2, L1 to 3, and 2 to 3. We should have equal resistances, right? If unequal, we're going to replace that inducer motor. These inducer motors hardly ever fail. You know, really, it's a 3-phase wrap, pretty simple. 3-phase motors are very simple inside. So usually not the problem, but definitely worth the check to make sure we got an okay motor here. If equal, we're going to go to step 3. If the thermal overload is open, the motor's hot, obviously it should be very hot. All will read open. And I'll get back into the questions here towards the end, guys. So step 4, we're going to remove the inducer motor. We're going to make sure that it can spin. It's free of any kind of debris. Make sure there's not a bird fell down in the flue pipe, creating some problems, right? Verify that it spins freely, right? If the wheel's clean, spins freely, all the previous checks are good, we're going to replace that IFC, right? We're going to replace the main control board. We get a lot of questions in tech on the gaskets for the inducer motors, from the round inducer motor mouth to the actual fitting on the heat exchanger. The fitting on the heat exchanger that is squared around is an RCT. That's what the actual factory name is. And it is sealed with high heat silicone. So there's no O-ring there or gasket to purchase. It is simply RCT silicone, RCT fitting silicone. Okay, so I think of red high temp silicone. All right, so troubleshooting. We're going to check resistance. Meter should be set on the highest ohm rating. Infinite resistance should be measured. Should be measured if any ohm value is measured, replace inducer. Okay, so we're checking the ohm values between 1, 2, and 3. Highest ohm setting on your meter. They should all be equal and even. Okay, two-stage S furnace. We have a PSE motor here, non-variable. So first stage winding resistance will be 103 ohms. Second stage winding resistance will be 54. We do get questions once in a while on these run caps, the 3 or the 5, I think they're 3s. Warranty on them. Train sees these as a whole unit, right? So you're gonna, if you for some reason want to warranty that run cap, you're gonna have to warranty that a whole inducer shell. I know it seems crazy, but it costs more to run the paperwork on that $3 cap than it would be to warranty that whole inducer shell. That's how they see it, as it's one big kit, right? So if you have to warranty for a run cap, you're going to have to replace this whole thing. So 103 for first stage, second stage is 54. All right, so variable speed 3-phase inducer motors. Obviously, we're going to look, is PS1 open? So we're going to check for volts AC on terminals to 24-volt common. So on one, there should be 24 volts, others should be 0. So of course, no, we're going to replace the switch. Yes, we're going to go to the next step, right? So we're looking to see what's there. So open limits, a 4-flash or an EO4. These can be a couple things, right? This can be several things on the 40-inch furnaces, right? So we have a thermal limit open. The blower is going to continue to run to try to cool those limits. So which limit open is what we need to ask. So we obviously have a main limit, which is the picture there on the 40-inch furnace. This is an 80% 40-inch furnace. So we're going to check delta T. We're going to check the blower, wheel, filter, coil, static, right? We're going to make sure the airflow is doing what it should be doing. That we're moving the air we need to move. Homeowner didn't have a filter that sucked down on top of the blower motor, something like that. Or we've had some filtration issues in the past, say a 7, 8, 9, 10-year-old furnace, no issues, all of a sudden having limit issues. Could be because some dirt was getting by those very plug filters. And now we have dirt on the secondary, if it's a 90, or we have dirt on the blower wheel, and we're not scooping the air like we should. So we're going to look at all these things. Coil spacer, it says remember coil spacer, that would be on the 17.5 wide furnaces and the downflow application. So they wanted a 3-inch spacer between them. So reverse flow limit. So we're going to check blower wheel, blower off delay. Maybe we're keeping the off delay not on long enough. Of course, we're going to check the trip temperature. Why are we hitting that? I would think on a 90% furnace, if we were getting reverse flow limits, I would think the secondary is impacted because we're holding heat tight to that blower motor, right? So we're going to look at all of these things in a 4-flash. So rollout limits, obviously we're going to have to check those too. That is part of that safety circuit. So we're going to look at our gas pressure. We're going to make sure it got converted properly if it was LP, right? We're also going to look for any kind of flue pipe restrictions that could cause rollout problems, right? If we can't get air out the flue pipe, we're getting the gas going the wrong way. We're getting that heat going the wrong way, right? So flue pipe restriction would be a big one. Block, not slow properly. Maybe that bird's dead in the flue pipe somewhere, right? Causing some problems. I would think that would show up as a pressure switch issue, but we can't rule it out, right? So burners clean, lazy flames, or burner crossovers are dirty. Burners clean is a big one. Seen it before where we get a little bit of rust or something like that, and that flame isn't being pulled as good as it should, or it's kind of lazy, if you will, and it'll the flame will stand up off the transfer a little bit and create some heat on that rollout limit. So we're going to make sure every time we touch a unit that it's clean and it's doing what it should be doing in the process it should be doing it, right? So we're going to look for flames tight and clean into the heat exchanger, so no disruption in flames when the blower comes on. So we get the question a lot when it comes to gas furnaces from homeowners and even technicians. And I'm going to kind of raise the question. You have an inducer motor putting a negative pressure on the heat exchanger. So you have a negative pressure, you have it monitored with rollouts, and you have it monitored with pressure switches. So we get the call all the time where, oh, the furnace is putting carbon monoxide into the space. That would be very hard to do, knowing that the heat exchanger is in the negative pressure. So it's being pulled through the heat exchanger and out the flue pipe. And then you're putting positive air that is greater than the negative air into the space around the heat exchanger. So you have positive air moving over a negative space. So if you had a crack in a heat exchanger, wouldn't the blower leak into the negative heat exchanger? Not the other way around. So when we get into heat exchanger checking and customer concerns, we always want to go to the return first and pull the CO2 number from the return. It could be something else in the space. Could be the water heater, natural draft water heater not drafting properly. Could be a cooking situation within the home. So we're always going to check everything, right? We're really going to break it down. So we're going to look at the flames tight and clean to the heat exchanger. So in that situation with a negative heat exchanger with positive air around it, if you had a crack in the heat exchanger or compromised heat exchanger, wouldn't you see flame disruption? Because now you have positive air pushing it on negative space. And that's when you would see rollout issues. So if that heat's coming forward of that heat exchanger, it's got to be something with the airflow pattern in the heat exchanger itself, right? Something is happening there. Something to think about. Airflow and static pressure. So gas furnaces, we're actually going to go after the filter, and then we are going to go below the coil. So we don't care what it's after the coil. We want to know before the coil for airflow static pressure. So we're going to compare that. So we're going to get an old 40-inch furnace. This is a PSC chart. This is a newer S9 V2 chart. And so once we pull that static number, we know, like on this example, we'll pick an upflow 80,000. We're going to go, okay, we're on medium high, we're on blue. I had a 0.5 static, a perfect 0.5 static. I'm moving 1280 CFM. So we're doing the math for you, right? So on this S9 V2 furnace, 100,000, we're going to go, okay, we're in first stage heating. Our airflow target in this situation is medium low. So at that 0.5 static, we're moving 1242. So we're obviously having to move more air, right? Because this is a different furnace, right? So 95% are going to use more air than the old 80%ers. So then we're actually giving you the temporize that you should be at 47. And then we're actually giving you the watts of the blower motor. Okay. So we're giving you all you can. You simply need to pull the static number to be able to verify that. Okay. So all these are marked factory settings. So from the factory, first stage is going to be high, second stage will be high, and of course you can adjust it down depending on what you need here. So flame sense without flame presence. So we have a 5 flash or an EO5. Flame is sense without power to the gas valve. So I simply cut this out of the S9 chart. So you have the 5 fault code. It actually walks through very clearly what you have for a fault code there. So inducer and blower will run on the 40-inch furnace. The gas valve could be stuck open or even a bad control board. So really what you're going to want to do is you're going to want to utilize the service vacs or and get this information out of here. So you can see on the S9V furnace, giving you a very nice call out saying, okay, we have a 5 flash. So is the flame been seen with a no call for heat, no or yes? And you're simply going to move down these charts to be able to help diagnose this stuff. So moisture debris in the inlet screen, we have seen that from not so much the manufacturer's end, but those 90% furnaces come with a U-bend. And for some reason, some people find it hard to get that U piece out. Instead of removing 4 screws, the installer will just take the Sawzall to it. So then they Sawzall through that U-bend, remove it, and then they pipe in what they need. Well, now they've put a lot of debris in that inlet gas screen, and we start to have problems, right? So we're giving you very nice flow charts to be able to troubleshoot this. So 115 volt power reverse, ground fault, igniter fault. So this would be a 6 flash, or respectively on the shorter furnaces, we're going to get a 6.1, 6.2, 6.3. Okay. So obviously I just stole one of the fault codes out for the faulty ground. But there is several of these flow charts in the service facts for those model furnaces. So hopefully you guys got literature racks or something like that, and you're keeping it with the homeowner, or the homeowner's got it somewhere where you can access it and troubleshoot. So ground fault, polarity fault, or low line voltage. So you're going to measure neutral to ground. If you get more than 10 volts AC, then there's an electrical problem within the home, right? If you get 120, then the polarity is actually reversed. So should check hot to common on the control board. There should be 120 volts there. Check ohms of the igniter, 6.3. And then of course, electrical problems could exist within the home. So we have had situations where older homes get newer furnaces. Worked fine on the old diesel burner system that they had, but they haven't, like say, an Edison circuit within the home. And when we check across what we would consider black and white, we have 120 volts. But then soon as we go L1 to ground, L2 to ground, we have a mix of voltage, like 60 and 60 or 80 and 20. So those would be electrical problems, incoming power to the home, right? That would be like an Edison circuit or something like that, causing you some issues with your newer furnace. And then that could also cause flame rectification problems, bad ground, stuff like that can cause that as well. So these codes you're going to really dig into power-wise, high voltage. Okay, gas valve circuit errors, 24 volt present at the gas valve when it should not be. So this is a very short fault code segment in that book, right? It says remove call for heating. Is 24 volt nominal voltage present between red lead at gas valve and connection to chassis ground? So that's burner ground. If yes, we're going to correct the wiring, check operation. If no, replace the control board, right? So this is very direct code. So it's either the control board or the wiring here, guys. So low flame sense, an 8 flash or an E08. So we're giving you a very good call out of troubleshooting flow charts here. So we talked about flame rectification. So we're sensing flame current less than 1 microamp. We have to check voltage on flame sensor should be around 80 volts. So I guessed right there. I remembered right anyway. So 80 volts at the flame rod prior to lighting. So we're going to clean and replace the flame sensor. Leather, fine grit sandpaper, dollar bill works fine. I wouldn't go too big on the sandpaper. I mean, AAA still will work just fine because you don't really want to sand it per se. You don't want to create valleys in that sensor. So very fine grit sandpaper. So low flame sense on an 8 flash. Board's not seeing that microamp DC callback. Okay. So 40-inch furnace, we're going to get this is a 9 flash, right? So igniter fault, this is 80 volt. So we're going to check the igniter, 11 to 17 ohms. There also is a triac in the control board. So you can see that picture of that good triac, and then on the left there, and then on the right, you can see the picture of the damaged triac. So It could be something on the control board in the 9-flash 40-inch furnace market. All right. The number one code that's called into tech services, other than maybe idle. So the 40-inch and the S9, right? So we have inducer limit, right? We have a limit open on the inducer motor when it's cold, right? So if yes, replace the limit. No, check venting terminations, gas pressures, right? So this would be more of the 40-inch furnace, this top one here. On the S9 furnace, you still have a limit on the inducer motor, but it is tied in with the pressure switch that monitors the drain trap here. So that's the condensate pressure switch. It's a 1.0 switch. When the trap is plugged, it fills and pushes air into the pressure switch chamber, which then trips that switch, throwing the EO9. I've had calls in to tech before where some technicians are like, well, it's been installed for 3 years and now it's having these problems. It's all down to pretty much one situation most of the time, which is this one right here. Okay. Have to have a vent, an atmospheric vent coming right out of that furnace. So as it comes down, however you bring it out, whether it's sidewall or down to the base in this downflow model, we got to have an atmospheric vent here. But also remember, if you have a random trip on a windy day, it's because of that wind, right? It's putting air through that heat exchanger system and that switch is noticing it. So that intermittent 9.1, right? So, but 90% of the time, it's the installers forgetting to put this dog leg in there and actually vent to the atmosphere. All right, so 10 flash, it's pretty direct answer, right? So board has detected an internal failure. We're going to replace the board. It has noticed something's wrong and it has just shut down all operation. So we're going to simply replace the board with a 10. So gas valve failure, this is going to be an S-series furnace only. So we're going to remove a call for heat. We're going to check for 24 volts at the gas valve. If yes, check wiring. If no, replace control board. So yet again, very nice flow chart here, right? So remove call for heating. We're actually asking you to go to brown lead at the gas valve to the chassis ground. And no, yes, right? If yes, check wiring, correct operation. If no, replace the control board. Okay, so blower mismatch, S9B2 only, E13. So verify that the correct horsepower motor is installed in the unit. So this is going to be based off of the personality module's information and what the motor is sending back as far as, hey, here I am, here's what I do, right? So that personality module is programmed for a 3/4 horse, whatever. And that motor has to be willing to accept that packeted information, right? So it's a direct call out from that module there. So could be if you're trying to make something work, right? That motor can't take that programming, or it's the wrong programming for that motor. All right, almost done here, guys. So PM missing or bad S9B2, that's an E14. So personality module is not on the board. Honestly, we get this call very rarely. When we do, it's typically, well, I just replaced the control board and now I'm getting an E14 error. Okay, what did you do with the old control board? Well, it's still in my van. Okay, we'll go get the personality module off of it and put it on the new board. If you have a new board and you put the personality module on and it power cycles and you power cycle it on, you shouldn't have a problem there unless there's a problem with that personality module, which you'd have to replace it. They are serialized and orderable from the factory. It's not something we stock, because they're serialized to that specific piece of equipment. So you'll have to call down to your Gensco branch. They overnight them typically. So if you order them before a certain time, you'll have them the next day. They're very good about doing that. But simply what it is. So most of the time I just replace the board and I have this error now. And we simply tell the technician to take it off the old board and put it on the new one. Okay. So blower communication failures, S9B2s, verify all connections from the board of the motor. So there is some connectors there at the actual at the gas furnace board there. There's a motor connector, which goes into this plug that goes through that essentially firewall, I guess you could say. And it actually goes into a connector there at the actual, could be plugged straight into the motor depending on the type of motor, or could have a little whip like this where it plugs in. So you'll want to check these connections, make sure all these connections are good and solid. Maybe we had a pin backed out. Maybe when they got reinstalled, when they changed the blower motor, maybe they didn't make this connection really well, or one of these connections really well. Or maybe when they made the connection, a pin backed out, right? So we're going to inspect and make sure and confirm everything is tight and where it should be and plugged in correctly. And if you've never seen reverse flow limits, here's a picture of one right here. So we have these two yellow limits, and here's your reverse flow temp limits, which would be tied into the 4-flash, right? So on the 40-inch furnace, it's on the blower deck, actually, not on the it could be on the shell, but usually on the blower deck. So if you've never seen them, there you go. All right, so blower comm failure, control S9V2, so this is an E18. So we're going to remove the 4-pin motor connection to the blower. Does the error change to an E17? If yes, verify the connections as in the E17 failure. We're going to do a blower go no go test with a TechMate tool, a Zebra, whatever you got, or you can even hardwire if you have to. A little bit harder of a process. If the blower motor comes on that go no go test, then you're going to replace the control board. All right, so questions. Let's start at the top here. Can you adjust pressure for DT, or do you have to do airflow? You want to do airflow for temp, right? Your gas should be running at rated, so you don't want to cut your gas back too much. You know, depending on your elevation, of course, and all that, you may have to scale your gas pressure for high altitude or something like that. But you should always have your temp rise with the gas pressure required for that valve. So if it could be a ductwork issue, right? Could be a blower speed issue, could be a static issue. So you should always have the temp rise required, or within the temp range required for that unit at your normal gas valve running range. Hopefully that answers that question. What does it mean when you have a new flame sensor, but the flame rectification DC volts is going from 5 all the way up to 11 within seconds? Could be that it's a new flame sensor and we're burning off a little bit of oil, right? And so we get a little bit of a hotter sensor than normal. Could also be placement of that sensor, but it should normalize down to 2 to 4. I've seen them at 6 here and there when I work with Lennox products. Sometimes they would pretty regularly run around 6, but 2 to 4 would be the window. I would say that's a new sensor, probably burning off oil. And just getting a little hotter than it should right there at the beginning. So personality modules and furnaces. What a personality module is those Panasonic motors. They're Panasonic. When we buy them, they are blank. They do not have any programming on them. So when we're used to the old 16-pin variables, you'd have to go down to Gensco and buy the motor hub end, right? The module end, if you will. And you'd have to have them programmed for your furnace. So we know you have an 80,000, and this is the personality, or this is the blower, how that blower is going to run and react. So we would program that, and then you put it on the motor, and that's how it would react. Well, those personality modules basically do the same thing. They are the motor programmers. So they have all the blower data information. So the reason why Panasonic decided to do that, instead of the old 16-pin, 18-pin blower motors, if you lost the programming that module, you'd have to take the module off, haul it down to Gensco or whoever the provider was, and have it reprogrammed if it was still good. Just to put the data back on because of a power bump or whatever. If it lost it, you'd have to get it reprogrammed. So now with the personality module, we don't have to worry about that. That profile, that information is all saved on that memory stick. And anytime that unit has a power bump or loses programming in that motor, we can it'll simply reprogram itself with that personality module. So that's basically what it is. It's the blower profile. Personality module is what PM stands for. I don't have a printout of the presentation. It's pretty hefty to send. Can a furnace that is not trapped? These are being recorded, guys. So if you really want this recording to play back at any time, talk to your rep and have your rep ask to post this video online, and you guys can watch it anytime you want. So let's see. Can a furnace that is not trapped cause a failed heat exchanger or plug trap? Can a furnace that is not trapped? Not trapped as far as the dog leg or the atmospheric. No, because we would trip on that E09 and drop operation of that equipment. If you're talking on the standard high wall 40-inch furnaces, typically no. I would see pressure switch errors. So if the heat exchanger was holding on to water or some sort because of a plug trap, we wouldn't be able to move air through that heat exchanger, and we'd have pressure switch issues typically. So hopefully that answers that question. So if we don't see the same voltage on inducer legs for 3-phase, the board is faulty. Not so much same voltage. Remember, we're not checking voltage. We're just checking ohm value. So we're ohming out just the inducer motor, unplugging the inducer motor, and checking from the plug to the motor itself, making sure they're all equal and even. If they're all equal and even, nothing's open. Let's say you get 6.6, 0.6, 0.6, that motor's fine. Okay. If you get, infinity on one, then you get, 0.2 and 0.3, that would be a bad motor, right? So then you would replace that inducer motor. But like I said, those variable speed inducer motors hardly ever die. How long has the residential mod valve been out? That mod valve has been out for a long time. I have a mod furnace in my personal home from 2012. That was right around the time they came out. I want to say 2010 to 2012 was kind of the range when we started seeing them. So they've been out quite a while at this point. Any other questions for me, guys? I'm more than willing to look back at slides if need be. And if there's no more questions, I'll go ahead and let you guys go for the day. Thanks for coming out. Your quick hitter for Tuesday morning. Hopefully you learned something and pick something up.